everybody, and welcome to a video where we're going to work through some examples involving conditional probability. In the last video, we introduced the concept of conditional probability, and we ran through some basic rules that we can use to compute conditional probabilities. Today we're going to put those to work in a couple of examples. So this example I'm going to take from the Skirms textbook, the chapter on the probability calculus, and it's a problem involving cards. So these are going to be conditional proba examples involving cards. All right. So we're going to assume again we have a standard deck of cards, which remember has 52 cards in it. And we're going to suppose that we're going to draw a card and then not replace it, set it aside, and then draw another card. All right. Now we're going to assume that on each draw, each of the cards in the deck has an equal chance of being drawn. All right. So the first question we're going to ask is, what's the probability of drawing an ace on draw 1? Well, with these sort of questions, right, we have all these formulas and simple rules we can use to compute probabilities, but it's often good to first just think intuitively about the proposition or the statement that we're trying to assign a probability to, and see if we can just assign it its probability directly. And in this case, right, we can, because, right, it was given to us that each deck in the card, or excuse me, each card in the deck has an equal probability of being drawn, so the probability of getting an ace on draw 1 is just going to be equal to the number of aces we have in the deck over the total number of cards we have in the deck. So we know that there are 4 aces in the deck. So it's going to be 4 over 52, right? All right, if we wanted to break this down even further, right, we could realize that drawing an ace on draw 1, that's really the same thing as drawing either ace of spades or ace of clubs or ace of hearts or ace of diamonds. Each one of those statements is mutually exclusive with all the others, and each one has a probability of 1 out of 52 attached to it. So we can sum up those probabilities, 1 out of 52, plus 1 out of 52, plus 1 out of 52, plus 1 out of 52, and we get this number that we got here, right? 4 out of 52. All right, so this is a pretty straightforward question. Next question we want to ask is a question about conditional probability. Right? What's the probability that we would get a 10 on draw 2, given that we get an ace on draw 1? Now again, right, we have some formulas for thinking about conditional probability, but let's try to assess this directly and commonsensically. So we're supposing that we've drawn an ace on draw 1. Now we're asking, what's the probability we're going to get a 10 on draw 2? Well, how many cards in total are left in the deck by the time we get to draw 2? Only 51 cards, right? Because we've taken out that card that we drew first, right? So we have 51 cards total left in the deck. How many of them are 10s? Well, supposing that we drew an ace on the first one, there's still going to be 4 10s left in the deck, right? So the chance of drawing a 10 on the second draw is going to be 4 out of 51, right? Notice it's a little bit higher than the chance of drawing a 10 on the first draw, but unconditionally, which would be the same as the probability of drawing an ace on the first draw. Because now on the second draw, once we've learned that we've gotten a card other than a 10 on the first card, or the first draw, it's more likely that we'll get a 10 next time, because there's less overall possibilities, but still 4 10s to be drawn. All right. Next question. What's the probability that we would draw? What's the probability that we would draw an ace on draw 1 and a 10 on draw 2? So this is we're asking for the probability of a conjunction. All right. So now we can use our conjunction rule, right? In particular, right, we can use general conjunction rule here. So recall what general conjunction rule said. It said that the probability of a conjunction, right, A and B is equal to the probability of one conditional on the other. In this case, I'll do 10 on draw 2, conditional on ace on draw 1, because we already figured out that probability, times the probability of the one we're conditioning on, the probability of ace on draw 1. And we already know both those probabilities, right? We just figured them out. It's 4 out of 51 times 4 out of 52. Right. So that's going to be our probability for drawing an ace on the first time and a 10 on the second time. All right. Next question. What's the probability that we would get a 10 on draw 1 and an ace on draw 2? So now we're flipping it. So now we want to know what's the probability we'd get 10 first and then an ace. Right? Well, there's nothing really different here about, ace and 10s are different ranks of cards, right? But neither one is more likely to be drawn first or second, right? So this question is really, right, we're going to get the same answer we got last time, right? And if we want to, right, we could break it down to see that, right? We get probability of, again, we can write it the exact same way, right? Probability of 10, draw 2, given, because we're using just here the general conjunction rule again, times probability of ace, draw 1, right? Which is just the same thing, right? 4 out of 51 times 4 out of 52. All right. Now the next question is, what's the probability that we get an ace and a 10 in our two draws? Probability of ace and 10. Now, here we have to realize that this could happen in two ways. We could get an ace and a 10 in one of two ways, right? We could get either a 10 first, or we could get an ace first, right? So this is really probability of ace and 10 is going to be the probability of, I'll write it below to give, actually I'll expand a little bit. There we go. Right, we can substitute in a logically equivalent proposition by our logical equivalence rule. This is going to be the same as the probability of ace on the first draw and 10 on second, or we get a 10 on the first and an ace on second. Okay? Now, this is the probability of a disjunction. These two disjuncts are mutually exclusive, right? You can both get an ace and then a 10, and also get 10 and then an ace, right? Those are mutually exclusive events. So, or the probability of their conjunction is 0. That's what really matters. So, this can be equal to the probability of the sum of the probabilities of the disjuncts. So the probability of ace on 1 and 10 on 2 plus the probability of 10 on 1 and ace on 2. And we already figured out what the probabilities of each of those were, right? It's going to be 4 out of 51 times 4 out of 52 plus 4 out of 51 times 4 out of 52. Excuse me, 4 out of 52 to, let's see, 4 out of 52 times 4 out of 51. Right? The order doesn't matter there, right? So what matters is that we're adding up the same thing twice, right? 4 out of 51 times 4 out of 52 plus the same thing. All right. So that was an application of additivity, or we could have seen it as an application of general disjunction rule, right? It's just that the probability of the conjunction that we're subtracting off in the end is going to be 0 in this case, because they can't both happen. All right, next question. What's the probability we would get 2 aces? Right, so an ace on the first time and an ace on the second time. So probability of 2 aces. Well, right, this is really a conjunction, right? So we can think of this as the probability of ace on 1 and ace on 2, right? And then we can use general conjunction rule, which we've used before, right? So the probability that we would get an ace on the second time, given that we got an ace on the first time, times the probability we'd get an ace on the first time. Now, here, right, we know the probability of getting an ace on the first time, right, is just 4 out of 52, since there's 4 aces in the deck, 52 cards total. And the probability of getting an ace in the second, given that we got an ace the first time, well, again, it's going to be out of 51, because there's 51 cards left in the deck on the second draw. But supposing that the first card we drew was an ace, there's actually only 3 aces left. So this one's going to be 3 out of 51 times 4 out of 52 as our final answer here for the probability of getting 2 aces. Alright everybody, thanks for watching this video on some simple card examples involving conditional probability. In the next video, we'll look at some simple coin examples involving conditional probability. So tune in for that, and please remember to complete the participation poll for this video, and I'll see you next time. Thanks guys!